So I wanted to do one more of just point of inflection, just doing the second derivative. I'm going to go through the whole thing. And then the next video, I'm going to put it together. I'm going to do a first derivative and a second derivative in one video, okay, and then graph it. All right, so here we go. So here's our function, x to the fourth plus 4x cubed plus 15. First step is we have to find our second derivative. So we have to walk through the process of finding first derivative first. So using power rule. So again, drop this to the front, subtract 1. Drop this to the front, multiply, and subtract 1. 15 just goes to 0. That's my first derivative. Second derivative is I take the derivative of the derivative. Drop this 3 to the front and multiply, and then subtract 1. Drop the 2 to the front and multiply, and subtract 1. Now I found my second derivative. Now I'm going to set my second derivative to 0 and then solve. So I'm setting it to 0. Factoring is usually the easiest way to do this. Since I have an x squared and an x, I can't just move this over. I have to factor out an x and get x by itself. So I can factor out a 12 and an x. That's in common to both pieces. When I divide that off of here, I have an x left. When I divide 12x off of here, I have a 2. So there is my factored function. So now I can set both of these terms to 0 and solve. So 12x equals 0, so x equals 0. I can solve for this one, x plus 2 equals 0. Subtract 2 from both sides, so I get x equals negative 2. These are my possible points of inflection. Okay, just like the critical points. Solve, get your x values. Those, because I'm doing second derivative, I know those are my possible points of inflection. So now, next step is I'm going to set up my test chart. So let me give you, let me write these down. And this is, I need to write this down so I can test my points. Okay. And if you notice, I wrote it again, I wrote it in my factored form. It's just easier for me to, because again, I don't care about values. All I care about is it positive or negative? So I'm going to set up my test chart. This is my number line. Notice I am labeling it. I'm going to put it in order, so negative 2 and 0. Make sure your number line is set up the way it's supposed to be set up from low to high. And now I'm going to find my concavity. Is it positive or is it negative? So because I have two possible points of inflection, now my number line is broken up into 3 intervals. Okay, so I'm going to pick a value in this interval using my second derivative. So negative 10 works. Now I plug negative 10 into my second derivative. That's why you label it, because it tells you where to plug it into. So 12 times negative 10 is a negative. And then negative 10 plus 2 is also a negative. So a negative times a negative is a positive. That means this interval is concave up. Now I jump to here. Between negative 2 and 0, negative 1 is a great value. Again, I don't want to use the possible points of inflection. I want to use any numbers in between. So I plug it in. 12 times negative 1 is a negative, times negative 1 plus 2 is a positive 1. So I have a negative times a positive, which makes that thing negative. So this interval is concave down. Okay? Now I'm going to test this interval. So with second derivative, I'm going to use 1. 12 times 1 is a positive. 1 plus 2 is also positive. Positive times positive is positive. That makes this interval positive. So what this tells me, since I went from positive to negative, negative 2 is a point of inflection. Here I went from negative to positive. So 0 is also a point of inflection. So I have 2 points of inflection. So where am I going to write this? So POIs are 0 and negative 2. So now, and notice I like my chart because my chart is going to help me graph. it shows me where it's going up and down. So because I know that these are both points of inflection, I need to plug those values back into the original function, all right, back into the original function, and then solve. So I know exactly what point or where on my graph the curvature is changing. So when I plug 0 in here, I get 0. Plug 0 in here, I get 0. 0 plus 15 is 15. So my first point of inflection, or where it curves, where it changes the curve, is at 0, 15. And now I'm going to do the same thing, plugging it back into the original function at -2. So this one I'm going to have to use my calculator, oops, and make sure I write the right numbers. Okay, so -2 to the 4th power is 16. And please make sure that you use your parentheses. So this is a positive 16. And then -2 cubed is a -8. So -8 times 4 is a -32 plus 15. So we have 16 minus 32 plus 15, which is a -1. So my other POI is at the value -2, -1. -2, -1. So what this tells me is if I were to graph this, so let me show you a quick little sketch. So remember, we're just sketching, right? We don't have accurate values yet. So we're just sketching. So at 0, 15, there's one where it changes, right? It changes. It goes from down to up. And then at -2, -1, this is also a POI. So here, something's going on here where it's curving up, then down. So that's the point that it changes. So it's curving up, and then right at that point, it starts going down again. And then at this point, it starts going up again. Okay, so we don't know exactly how that works, but it's going curving up and then curving down, and then at 0 it starts curving up again. So this is our down curve. This is our up curve. We don't know exactly because we don't have the first derivative yet, but we're going to find it.